Good day. We're carrying on from the last video that started with percent composition and moved into empirical formulas. These were the steps that were outlined that we're going to try to drill into your head. Find the mass of each element, convert to moles of each element, and then find the ratio of moles of each element. And once you have that, you'll get an empirical formula. If you have to get a molecular formula, then you have to do crazy step D. And it looks all exotic, but it's not too bad. So let's get right at this example here. And you do have PowerPoint notes on these, so you should have plenty of room to fill in what's going on. We're told we have nitrogen and oxygen. In this case, it tells us the mass of both nitrogen and oxygen, and it says find the empirical formula. So that's what we're going to do on the upcoming slides. Periodic table, have it handy. So step A, we're just converting our masses to moles. So we took the 4.20 grams out of the question, divide by the molar mass of nitrogen. We do the same thing for oxygen. And we get this 0.300 and our 0.750. So that was step A, and now we have finished step B. Looks pretty easy. Now I look at these two numbers. Step C says I'm going to take this number of moles and divide it by 0.300 moles of nitrogen, because I divide by the smaller number. So we'll do that right here. Now, this is for emphasis. If I have 0.300 moles of nitrogen divided by 0.300 moles of nitrogen, I get a ratio of 1.00. Notice no units, the units divided out. I do the same thing for the oxygen, I get 2.50. So these would be my subscripts, and I have to recognize I have more nitrogen than oxygen. By convention, nitrogen comes first, so I write down N1O 2.5. But the problem is I'm not allowed to have half an atom. My answers have to be integers for these things. So to get around that, I'm going to double the 1 and I'm going to double the 2.50. So my 2.5 to 1 ratio becomes a 5 to 2 ratio. So I end up with N2O5. I figured out the empirical formula, and typically these kind of questions are out of 3 or 4 marks. If you have to find a molecular formula, usually that's just a 1-mark deal. We'll do one more example here, and then we'll start another video. Now, 45.00 gram sample of lead, oxidized, resulting compound has a mass of 51.95 grams. And it says, hey, this is going to be made of lead and oxygen. And you're looking at the question going, whoa, whoa. It didn't tell me how much oxygen's there. Well, it did tell you what the total mass of the compound is. So 45.00 grams lead, the rest has to be oxygen. So I take that number and I subtract that number, and I'll have my oxygen. That'll be what I do in step A. Periodic table is your friend. So that's what I'm trying to work out. The X and the Y, I'm trying to work out the subscripts. So I get 0.2172 moles of plumbum. Now the 6.95 did not come from thin air. I went boom minus bam equals BIM. I divide by the molar mass and I get 0.434. This is a smaller number. So here are my answers to part B, or step B. I'm going to take this number of oxygen moles, divide it by the moles of lead, and I'm going to be home free. You probably can tell by inspection what we're going to get, but these are examples. We want to be thorough. So we get the lead, gives us 1.00, no surprise there, divided by the same number. And we end up with 2.00. Well, these are nice numbers that easily round to integers. So I'm going to get lead 4 oxide, which is PbO2. That's a good place to wind down this video, and we will carry on with another video as we grind through this tremendous PowerPoint.